Hi everyone, welcome to Friday's lecture for 1/15/21. You can complete this assignment at any time as long as it's done before midnight. So before we get started, I wanted to just go over the Canvas page to make sure everybody's clear on what is due this week. Your syllabus quiz due January 15th. The week 1 assignment STEAM cycle review is due January 15th. The reading assignment should be done by January 15th, but you don't have to pass anything in. Week 1 quiz is due January 15th. And then there's a really cool short video I found off YouTube. I think you'll like it. Please check it out. It'll hopefully connect some of the dots. These two things are the lectures from Monday and Wednesday, and I will have this also uploaded for your review as well. And this will be attendance credit. And then the PDF of all the pictures and stuff that I was talking about throughout the week is located here. If you missed a class, your makeup quiz will be here and your Zoom link. And I'm going to try to keep this set up while we are doing this online learning. So let's talk about nucleate boiling and departure from that. So nucleate boiling, which you can see right here, is what is occurring during normal operations. It's a good thing. Our tube temperatures are pretty stable. Our water is traveling at 5 to 7 feet per second throughout those tubes. That's pretty fast. And things are happy. Things are great. Now if you are not paying attention and you're adding too much fuel to your boiler and you're reaching max capacity, you have to worry about, pressuring your drum, which you have safety relief valves, but you also have to worry about the temperature of your tubes. The reason being, you can reach this thing called transition boiling, and that occurs when things start to heat up and bubbles start to stick to the walls of the tubes, and the air is starting to insulate those tubes. And what happens when tubes are insulated? Your metal of your temperature starts to increase. So that's not good. We were at 675 degrees Fahrenheit. Now we're at 1,000 degrees Fahrenheit. Things are going to get weird. At that point here, that's called departure from nucleate boiling. Not a good thing, because the next stage is film boiling. And film boiling can also be referred to as gas film boiling. The Coast Guard calls it gas film boiling. This is when the boiling of the water is only happening on the sides of the tubes. And when that happens, you'll see that we have a drop in temperature. That's only temporarily. And that drop is occurring because since the water is flowing faster, because it's boiling and we're creating more flow through those tubes, we get this cooling effect, but that's only temporary. After that point, our tube temps are going to skyrocket again, and we're going to have major issues. You are going to occur a meltdown and the end point of circulation. Circulation, right? Not a good thing. Downcomers are typically located in a cooler part of your boiler. So if the fire is here in your boiler, they're usually just outside of your boiler or just inside, away from the heat, so that it causes that temperature difference, which is also going to cause you a natural density difference. And that's going to help you with your natural circulation. If you didn't have these downcomers, you're more susceptible to this endpoint of circulation, because your generating tubes would be in so much demand if you started putting too much fuel to your boiler that your water wall tubes would actually start acting all as generating tubes, and then your cooling effect in your boiler furnace would be less, so then it would just kind of be a cascading effect. So the key thing is, downcomers prevent end point of circulation. Natural circulation was designed to eliminate this departure from nucleate boiling. So let's continue on with the boiler review. We're going to talk about boiler furnaces right now. So old style furnaces used refractory lined furnaces. And the Coast Guard loves questions about refractory. I don't know why, but they're obsessed with it. There's probably 2 or 3 pages just full of questions about insulating brick, insulating block, castable fire brick, and all that stuff. So I wanted to go over some of that stuff. But I want you to understand that refractory lined furnaces are the old style. And also they're used in older type fire tube boilers, but they're kind of the old style. The new style in water tube boilers, they use this thing called mono wall or membrane wall, and they're also referred to as water walls. So the nice thing about water walls is that it makes up part of your furnace, so all you need is this membrane of walls that are kind of connected, and these are all tubes that also can act as generating tubes. Those tubes only have like a little bit of insulation behind them and like sheet metal, and that's it. That's your furnace wall. So this is what is used in modern day applications, especially water tube boilers typically use mono wall or membrane wall. Refractory line furnaces have this stuff called insulating block. This is the outside of your boiler furnace. And then it goes to insulating brick, and then there's fire brick, and the bottom of your furnace will also be fire brick. Your burner, say it's right here, this is where the flame comes out, right? Around your burner in your furnace, so this is inside the furnace, is going to be plastic refractory. And then above that, in the corners of your boiler walls or furnace walls, plastic refractory has high temperature components, so it's really used for like special joints like around your burner, but in an emergency you can use plastic refractory to make a patch. Castable refractory is typically the stuff that is used to actually, fill in your joints and such. It fills in the gaps. It's really cheap. It's not very good for thermal shock, while plastic refractory is good for thermal shock. There's a lot more questions about refractory in the Coast Guard book, and because it's so outdated, I feel like you can probably read it the night before you take the test and you'll learn about it. There's a few questions about this stuff on the stationary steam test, but most of it is about these 3 components: insulating brick, fire brick, and insulating block, and just kind of know where they are in your furnace. I have a better picture of this actually right here, and this is on your slideshow, so if you don't like my drawings, here you go, take a look at this. So we've talked about the feed water cycle, the condensate cycle, the actual steam generator. Now I want to just make sure we're all on the same page about the flue gas path, or basically where the air is flowing out of the stack. So this is a typical setup for a large stationary steam type boiler, but all boilers kind of have the same components, give or take a few of these things. So let's go over this. So this is going to be your furnace right here. Obviously you can see the flames, which are your burners, and your fuel is fed into those burners, right? So we're going to talk about next. And in order to get this combustion in here, we need to add air, and that can be done naturally, and that would be natural draft, or it can be done by a forced draft fan, which would be this fan right here. And that's going to blow air into your furnace and help with combustion and make the magic happen in your furnace. So you can control that with dampers, which we will talk about in detail. And then your flue gas is going to come up, and there might have superheaters here, but that's a different system. And it's going to go through your economizer, right? And your economizer has your feed water going through it, which is the other system, down into some of your environmental controls. But I want to enlighten you guys about this device here, which is called an air preheater. And it's basically this thing that turns around in a circle like this, and it has these, there's a couple different designs, but a lot of them have these like ceramic pies in there like this. And these ceramic pie pieces get heated up as it turns through your hot stack gases, right? So this side is real hot, and this is your air coming into your plant, right? So this here is a little cold, so to preheat that air, this thing turns and it heats up the air going into here, and this thing would actually probably come out all the way out here. But I just wanted to show you that. I don't know why, but a lot of people don't understand what it is, but it's a pretty important piece of equipment used in stationary steam plants, and it's one of those things that it's going to make your life a lot easier if it is in service, because it's going to preheat your air and help with combustion and help accelerate the combustion process. So let's continue on. So it'll pass through your air preheater, and then it's going to go through your environmental devices, which could be a scrubber, which basically injects a lime slurry into the exhaust gases to eliminate SOx. And how I remember that is scrub your SOx. Scrub your SOx, you eliminate it. So that's a environmental concern that we're going to look how those works in a later class. Then there may be like a baghouse here, which is essentially a house of bags that collects the air. Will go through these filter bags and collect all the particulate matter, which is all the black stuff no one wants to see coming out of the stack. People get upset. So then it'll come out, and then it'll go through your induced draft fan, if it has one, and then it'll go out your stack, and there might be some Sims equipment here, to help tell you what your stack chemicals are, and if you're environmentally friendly or not. That's what's gonna tell you what's going on there. We're going to talk about that as well in this class. But I want you to just see the big picture of what's going on when we're talking about the flue gas path and the components that are involved there. There's also sometimes this other channel that I did not draw on here that might come off your flue gas path, and it might re-inject into your furnace, and there's going to be a fan here. And in a plant, it might be called the GRF fan, or your gas recirc fan. And those fans basically will take some of the ash and stuff that is coming through your stack, your flue gas path, and re-inject it to be burned in your furnace. So those are pretty cool. So that's what a gas recirc fan is. Again, we're going to go over this in greater detail, but just wanted to give you a quick overview of what a flue gas path typically looks like. And that's it.